Definition of differential equation. Definition: an equation containing independent variable and dependent variable and the derivatives of the dependent variable with respect to independent variable is called as a differential equation. That is a DE, differential equation. The differential equation can be classified into two types. First one is ordinary differential equation, and the second one is partial differential equation. Ordinary differential equation means an equation containing only one independent variable is called ordinary differential equation. Ordinary differential equation. Example: dy by dx plus 3 sin x is equals to 4. In this term, y is a dependent variable and x is independent variable. Second one, partial differential equation. An equation containing more than an equation containing two or more independent variables is called partial differential equation. Example, x into dou u by dou x plus y into dou u by dou y is equal to nu. Here x is an independent variable as well as y is also an independent variable. So this type of equations are called partially differential equations. Next, order of the differential equation. Order of the differential equation. The order of the differential equation is the order of the differential equation is the highest order derivative occurred in it. And next, degree of the differential equation. Degree of the differential equation. The degree of the differential equation is the degree of the highest order derivative occurring in it, and it is free from fractions and radicals. You know, radicals means under root, cubed root, square root, cubed root, fourth root, like that. So fractions power, a differential equation should not contain the powers and fractions power 3 by 2 and like that. These type of equations are called and this is called as degree of the differential equation. Next, one more example, the order and the degree of the differential equation d square y by dx square plus dy by dx whole cube whole power 6 by 5 is equal to 6y, or respectively first option 2 comma 6 by 5, second option 1 comma 18, third option 2 comma 1 and fourth option 6 comma 2. Given differential equation d square y by dx square plus dy by dx whole cube whole power 6 by 5 is equal to 6y. మనం ఇక్కడ అబ్జర్వ్ చేయాల్సింది ఏంటంటే differential derivatives should not containing fractions or radical signs, but x, y variables should containing either root functions or fractions. Only small x, small y, these variables are containing root functions or fractions also. But differential coefficients should not contain fractions. So in left hand side, it is power 6 by 5. It is a fractional value. Now raising power 5 by 6 times. Raising power 5 by 6 times. Now the equation becomes d square y by dx square plus dy by dx. The power raise, we have to raising the power in left hand side 5 by 6 times, that is equals to 6y whole power 5 by 6. Once I will explain, this is the given differential equation. Here 6 by 5 is a fraction. Now raising power 5 by 6 on both sides. 5 by 6 by 5 whole power 5 by 6. 5 will go and 6 will go. It is free from fractions, and 6y whole power 5 by 6. But this is 6 is a constant and y is a variable. But this function containing fractions. But these type of functions, differential coefficient functions, do not contain, should not containing fractions. Now in this differential equation, highest order derivative, this is the first order derivative and this is the second order derivative. Therefore order is equals to 2, and degree of the differential equation, we recall the degree of the differential equation, the degree of the highest order derivative. In this, what is the degree? Its degree is 1, but it is not 3. But it is a first order differential equation. It is containing 3. It is the second order differential equation. It is the highest order derivative in our obtained equation. In this, order is 2, that's why, and its power is 1, therefore its degree is equals to 1. Degree is equals to 1. Therefore order is, the given question is order and degree. Here order is 2 and degree is 1. Third option is the correct option. The order and degree of the differential equation y is equal to 5 plus dy by dx whole square whole power 4 by 3 whole divided by d square y by dx square is, or first option 2, 4, second option 1, 2, third option 2, 3, and fourth option 2, 4. Given differential equation is, given differential equation, DE means a differential equation, y is equals to 5 plus dy by dx whole square whole power 4 by 3 whole divided by d square y by dx square. Now cross multiplying y into d square y by dx square is equal to 5 plus dy by dx whole square whole power 4 by 3. In this right hand side, the equation containing a fractional value 4 by 3. Now it should not containing a fractions. That's why raising cubing on both sides. Cubing, if you are raising 3 by 4, again left side we are having a 3 by 4 fraction. In this left side, d square y by dx square is the differential coefficient here. If you are raising, in previous problem, raising 6, actually the problem containing power 6 by 5, we are raising 5 by 6. But right side is only 6 by there. It is right side function does not containing a differential coefficient. Here, both left side and right side terms are having a differential coefficients. We are raising only cubing on both sides. If you are raising 3 by 4 on both sides, again we are having this differential coefficient having a fractional value, but the differential coefficients should not contain fractions. That's why cubing on both sides, y into d square y by dx square whole cube is equal to 5 plus dy by dx whole square, dy by dx whole square whole power 4 by 3 into 3, 4 by 3 into cubing, 3 will go, then y cube into d square y by dx square whole cube left side is equal to 5 plus dy by dx whole square whole power 4. So it is free from fractions. Then its highest order derivative in the obtained equation is d square y by dx square. This is second order derivative and it is first order derivative. So order is 2. Therefore order of the given differential equation is 2, and degree is equals to the degree of the highest order derivative. In our obtained equation, d square y by dx square is the highest order derivative. Because of it is a second order derivative, dy by dx is the first order derivative and its power is 2. So highest order derivative is, order is here 2. Its degree means its exponent is 3, that is the degree is 3. Therefore 2, 3, order and degree is 2, 3, which is the required solution of the given differential equation. Order is 2 and degree is 3, that is third option is the correct option. M, n are the order and degree of the differential equation d power 4 y by dx power 4 plus d square y by dx square whole power 3 by 2 is equal to a into d cube y by dx cube respectively. Then m plus n is equal to 2m plus n. First option 11 by 2, second option 7, third option 11, and fourth option 7 by 2. Solution. Previously I told you one question, same fractions. So to remove these fractions, d power 4 y by dx power 4 plus d square y by dx square whole power 3 by 2 is equal to a into d cube y by dx cube. This is the given differential equation. Now raising square on both sides. Don't raising power 2 by 3 because of right side having a differential coefficient. If you are raising 2 by 3, it should containing 2 by 3 fraction. Again it is having a fraction value. That's why squaring on both sides. The equation becomes d power 4 y by dx power 4 plus d square y by dx square whole cube is equal to a into d cube y by dx cube whole square. That is equal to a square into d cube y by dx cube whole square. So in this differential equation, if you are expanding this in the form of a plus b whole cube, a cube means this first term whole cube. In this obtained differential equation, d power 4 y by dx power 4, which is the highest derivative obtained in the differential equation. Therefore, its order is 4. Order of the given differential equation, obtained differential equation is 4, and its degree, what is the degree? Degree is equals to 3. Degree is equals to 3. Therefore, the given m comma n are the order and degree. Here order is representation here m and n representation here degree. So m is equal to 4, n is equal to 3. Therefore, we have to find 2m plus 1. 2m plus n is equal to 2 into, here m is 4 and plus n is equal to 3. Here 2 4s are 8 plus 3, that is equals to 11, which is the solution of the given differential equation. Third option is the correct option. Next problem, the order of the differential equation whose solution is given by y is equal to c1 plus c2 into cos of x plus c3 minus c4 into e power x plus c5, where c1, c2, c3, c4, c5 are arbitrary constants. First option 5, second option 4, third option 3 and fourth option is 2. Y is equal to c1 plus c2 into cos of x plus c3 minus c4 into e power x plus c5. Here put c1 plus c2 is equal to a, capital A, and again this can be written as c1 plus c2 into cos of x plus c3 minus c4 into e power x into e power c5. Bases equal, power should be added. c4 into e power c5. These two are also again constants. And c4 e power 5 is equal to b. c1 plus c2 ni manam a ga consider chesamu. c4 into e power c5 ni another variable capital B ga consider chesamu. One more is there, x plus c3, it is also arbitrary constant. So how many arbitrary constants in the given differential equation? c1 plus c2 ni manam a ga తీసుకుంటే ఇదొక arbitrary constant, and these two are constants is taken as another variable, another constant b and c3. So here 3 arbitrary constants, totally 3 arbitrary constants. Therefore its order is equal to 3. So third option is the right option. Next question, the differential equation representing the family of y square is equal to 2c into x plus root c, where c greater than 0 is a parameter is of first option order 1 degree 2, second option order 1 degree 1, third option order 1 degree 3, fourth option order 2 degree 2. Solution, given y square is equal to 2c into x plus root c. In this given equation, c is the only parameter. ఇక్కడ మనం గుర్తుంచుకోవాల్సిన విషయం ఏంటంటే ఇచ్చిన ఈక్వేషన్లో ఎన్ని పారామీటర్స్ ఉన్నాయో అది దాని యొక్క ఆర్డర్ ఆఫ్ ద డిఫరెంట్ ఈక్వేషన్ అవుతుంది. c is the only single parameter, so its order is 1. Here C is the one parameter, therefore order is equals to 1. Order is equals to 1. Next we have to find the degree of the differential equation. And how to find the degree of the differential equation? ఎన్నిసార్లు మనం ఈ ఇచ్చిన ఈక్వేషన్ డిఫరెన్షియేషన్ చేయాలి అంటే మనకి ఎన్ని పారామీటర్స్ ఉన్నాయో అన్ని టైమ్స్ డిఫరెన్షియేట్ చేయాలి. ఇక్కడ సి అనేది ఒకే ఒక పారామీటర్ ఉంది కాబట్టి ఇచ్చిన ఈక్వేషన్ని సింగిల్ టైం మాత్రమే డిఫరెన్షియేట్ చేస్తాము. నౌ డిఫరెన్షియేట్ ద అబోవ్ ఈక్వేషన్ y square derivative 2y into dy by dx is equal to 2c into x, 2c constant, x derivative 1 plus 2c into root c, total it is constant, derivative of the constant is 0, so 2c. Now substitute this value in above equation, y square is equals to, don't cancel 2 because of here 2c term is there. Now substitute in place of 2c this value, y square is equal to 2c is equals to 2y into dy by dx into x plus root c value. Now we will cancel only here c value, 2 will go, c is equal to y root y into root of c value is y into dy by dx. Y is equals to 2 into dy by dx into x, you can multiplying with this value into x plus 2 into dy by dx into under root y into dy by dx. Y minus 2 into dy by dx 2x is equals to 2 into 2x into dy by dx. 2 into dy by dx into root over y into dy by dx. Now squaring on both sides, y minus 2x into dy by dx whole square left side is equal to 4 into dy by dx whole square into y into dy by dx, that is equal 4 into y into dy by dx whole cube, whole square into dy by dx whole cube. Here order is already decided 1 and degree is what? Our obtained differential equation is y minus 2x into dy by dx whole square is equal 4y into dy by dx. This is a first order differential equation. This is the highest order, so its degree is higher. Degree of the highest order derivative is the degree of the required differential equation. Therefore, degree is equals to 3. Degree is equal to 3. Therefore, order is 1 and the degree is 3. Therefore, third option is the correct option of the given problem. Next, variables separable method. If the given differential equation is in the form dy by dx is equal to f of x comma y, where f is a function of x and y, then that equation is called variable separable method, variable separable differential equation. We separate the variables x comma y and bring all the terms involving x ln to dx and the terms involving y alone to dy to convert f of x into dx plus f of y in plus g of y into dy, g of y into dy equal to 0, then we integrate. So if the given differential equation of the form dy by dx is equal to f of x comma y, where f is a function of x and y, then the equation is called as a variable separable differential equation. By using variable separable differential equation, we separate the variables x and y, bring all the terms involving x alone to dx and all the terms involving y alone to dy to convert in this form, then that is equation, and then integrating. For example, dy by dx is equals to e power x by y. For example, dy by dx is equal to e power x by y. By using separables method, all the terms involving x to alone to dx and all the terms involving y alone to dy. So how to write this equation? Y into dy, same variables, y alone to all the terms involving y alone to dy and all the terms involving x alone to dx, e power x into dx, which is converted in the form of f of x into dx plus g of y into dy, and separating the variables we can we can integrating. That implies integral of e power x dx is equal to integral of y into dy, and then we will get the solution of the differential equation. So e power x integration e power x is equal to y integration y square by 2 plus integral constant c, which is the solution of the differential equation. This is the example of this is separable variable separable method. If the given differential equation dy by dx is equals to f of x by g of y, f of x by g of y is a variable containing y terms, and to write these terms alone to dy and f of x alone to dx, that implies f of x into dx is equal to g of y into dy. Variables are separable, and then integrating. This is the procedure for overr. dy by dx is equals to g of y by f of x dx, g of y by f of x, and we have to write dy by g of y is equal to dx by f of x, and then integrating. Next question: if c is parameter, then the differential equation whose solution is y is equal to c square plus c by x is, first option, y is equal to x power 4 into dy by dx minus x into dy by dx whole square. Second option, y is equal to x power 4 into dy by dx whole square plus x into dy by dx. And the third option, y is equal to x power 4 into dy by dx whole square minus x into dy by dx. Fourth option, y is equal to x power 4 into d square y by dx square minus x into dy by dx. Solution: given y is equal to c square plus c by x, Here C is the parameter, single parameter is there. So now we can differentiating to form a differential equation. The differential equation, so differentiating with respect to x, then left side dy by dx is equal to c square is constant derivative plus c by x, its derivative is c into minus 1 by x square, that is equal to minus c by x square. Therefore, C is equals to minus x square into dy by dx. C value is minus x square into dy by dx. Now eliminating this parameter C, substitute C value in above equation. Y is equals to c square minus x square into dy by dx. It is the only value for c, c square plus c by x. C here, c is minus x square into dy by dx whole divided by x is here, c by x, x will go, that is y is equal to x power 4 minus whole square positive x power 4 dy by dx whole square, minus x into dy by dx, which is the required differential equation. So see, the option is 3. Y is equal to x power 4 into dy by dx whole square minus x into dy by dx. So which is the obtained differential equation of the given problem. Next question, the differential equation which represents the family of curves y is equals to c1 e power c2x, where c1 and c2 are arbitrary constants is first option y double dash is equal to y dash into y. Second option y into y double dash is equal to y dash. Third option y into y double dash is equal to y dash square. And fourth option y dash is equal to y square. Solution, y is equals to c1 into e power c2x. c1 and c2 are the two parameters. Now we can differentiating 2 times of the given equation. Differentiating, the y becomes y dash, first order derivative is equal, c1 is constant into function. Not only single constant, if it is constant, its derivative is 0. Constant into function is here, e power c2x derivative e power c2x. By the chain rule differentiation of chain rule, e power c2x derivative e power c2x into again derivative of c2x, you will get to c2, that is equals c1 into e power c2x into c2, which is equal to the given function y is c2, y dash is equals to. Now again differentiating this function, because of c1 and c2 are two parameters are here, we can differentiate in 2 times. Already one time is completed. Now again differentiating, y dash becomes y double dash is equals to c2 is constant and y derivative is y dash. Now y double dash is equal to c2 value from this here. This is considered as equation 1. From this equation, c2 is equals to y dash by y into y dash. Now cross multiplying, y into y double dash is equals to y dash into y dash y dash square. So which is the required differential equation of the given problem. Third option is the correct solution. Y into y double dash is equal to y dash whole square. Next problem, the differential equation obtained by eliminating the arbitrary constants A and B from xy is equal to a e power x plus b e power minus x is first option x into d square y by dx square plus 2 into dy by dx minus xy is equal to 0. Second option d square y by dx square plus 2y into dy by dx minus xy is equal to 0. And the third option x into d square y by dx square plus 2 into dy by dx minus y is equal to 0. And fourth option d square y by dx square plus dy by dx minus xy is equals to 0. In this problem, a and b are two parameters are here. Now the given equation can be differentiating two times. So given equation is xy is equal to a e power x plus b into e power minus x. A and b are the parameters. We can differentiating the given function two times. Now applying differentiating UV rule, applying left side here, product of two functions, first function into derivative of second function y dash plus y into derivative of first function is 1 is equal to a into e power x derivative e power x plus b into e power minus x derivative e power minus x into again derivative of minus x, we will get minus 1. Now x into y dash plus y into 1, y is equal to a e power x plus of minus minus b e power minus x. Next, again differentiating with respect to x, x into, again x into y dash means dy by dx or simply denoted with y dash. UV rule, x into y dash derivative y double dash, u into derivative of v. So here uv is x, v is y dash. X into derivative of y dash is y double dash plus y dash into derivative of x is 1 plus y derivative y dash is equal to a into e power x derivative e power x, and next here minus b constant, e power minus x derivative minus of e power minus x. Directly you can write it here before negative sign, minus of minus plus b into e power minus x. So it is equal to the given value xy. Therefore x into y double dash plus y dash into 1 y dash plus y dash, that is 2 y dash, is equals to a into e power x plus b into e power minus x, value is equal to xy. Therefore x into y dash nothing but d square y by dx square plus 2 into y dash means dy by dx is equals to minus xy is equals to 0, which is the required differential equation of the given problem. The differential equation of the family of parabolas with vertex at 0, minus 1 and having axis along the y axis. First option x into y dash plus y plus 1 is equal to 0. Second option, xy dash minus 2y minus 2 is equal to 0. Third option, xy dash minus y minus 1 equal to 0. And fourth option, y dash plus 2xy plus 1 is equal to 0. In the given problem, differential equation of the family of parabolas with vertex at 0, minus 1. 0, minus 1 means x coordinate is 0, y coordinate is minus 1. X coordinate is 0, lie on y axis. Y coordinate is present, x coordinate is absent. So this given point lies on y axis and having axis along y axis. So, parabolas, this is x axis and this is y axis, whose axis axis is the x axis, which is a right open or left open, or here axis is y axis along y axis. So that's why the parabola is either downward or upward parabolas. Solution. The family of parabolas with vertex zero, minus 1 and having axis along the y-axis is generally standard form of the parabolas with along the y-axis is x square equal to 4ay or x square equal to minus 4ay. These are the standard forms. But vertex is given here. Vertex generally denoted with a h, k. H is 0 here, k is minus 1. The parabola equation becomes x minus h whole square. X minus h whole square, will be in the form x minus h whole square is equals to 4a into y minus k. Y minus k here minus 1, minus of minus plus 1. The equation becomes x minus h is 0 here. X square is equal to 4a into y plus 1. 4a into y plus 1. Here a is the parameter. Now we can differentiating one time only. Differentiating with respect to x. Now 2x is equal to, for simply calculation, 4a into dy by dx nothing but y dash. So y dash a is equals to 2x, 4a is equals to 2x by y dash. The equation is, given equation is x square is equal to 4a into y plus 1. Substitute in place of 4a this value, x square is equal to 4a value is 2x by y dash into y plus 1. So parameter a is eliminated. Now simplifying, x square into y dash is equal to 2x into y, 2xy plus 2x. Now in right side you can take x common, 2y plus 2. Here left side is x square into y dash, one x will go. Therefore x y dash is equals to 2y plus 2. Therefore x into y dash minus 2y minus 2 is equal to 0, which is the solution of the given equation. That is the required differential equation of the given problem. Next problem, the differential equation for the family of curves x square plus y square minus 2a into y is equal to 0, where a is an arbitrary constant, is first option 2 into x square minus y square into y dash is equal to xy. And second option, x square plus y square into y dash is equal to 2xy. And third option, x square minus y square into y dash is equal to 2xy. And fourth option, 2 into x square plus y square into y dash is equal to xy. Solution. Given family of curves is x square plus y square minus 2ay is equals to 0. In this equation, in this family of curves equation, a is a single parameter. So we can differentiating only single time only. Now differentiating with respect to x, 2x x square derivative 2x plus y square derivative 2y into dy by dx minus 2a constant y derivative dy by dx is equals to 0. Now 2x plus 2y into 2y into dy by dx, 2y into dy by dx minus, from this given family of curves 2a value is, this implies x square plus y square is equal to 2ay. Therefore, 2a is equal to x square plus y square by y is equal to 2a. Substitute 2a value from here, x square plus y square by y into dy by dx is equals to 0. Now the equation becomes 2x plus 2y into dy by dx minus x square minus of x square plus y square by y into dy by dx is equal to 0. The equation becomes 2xy, take LCM here, y 2xy plus 2y square into dy by dx, 2y square into dy by dx minus x square minus x square into dy by dx minus y square into dy by dx is equals to 0. Here 2 times of y square into dy by dx, it is having positive sign. Here y square into dy by dx negative sign. That implies y square into dy by dx. 2 times of y square into dy by dx minus. So minus x square into dy by dx plus 2xy is equal to 0. Now the equation can be rewritten as x square into dy by dx. This negative term taking to right side, it will be positive and it will be negative, and keeping the term as it is, same left side, x square, in both the terms having a dy by dx term, x square minus y square into dy by dx is equals to 2xy, which is the required solution of the given problem. X square minus y square into y dash nothing but dy by dx. That implies x square minus y square into y dash is equal to 2xy. Third option is the correct solution of the given problem.